Well,
Thank you guys for joining. Today we're actually, hey Shauna, thanks for joining. Didn't expect you to
Hi
actually,
guys, hello.
Hi,
didn't expect you
Shauna.
to be there today. I saw your message from the store manager, follow up in 2 days. But anyway, we'll talk about that at another time.
Yeah, no problem. I mean, I'm driving, but I will be off camera, but I'm definitely being a part of the class today.
No problem, no problem, no problem. All right, we'll be learning about the running locally an LLM and having it locally run on your machine and interfacing with it. So it's gonna be an exciting show today. All right, AI Johnny, you ready?
I'm ready.
Okay. Thanks.
Later.
welcome to Season 11 of Airhead Institute, your 45-minute AI power-up at noon Eastern. This month, we are broadcasting live across all the socials and Zoom. If you're new here, join our free AI community to grow alongside other curious minds and give your kids a head start by enrolling them in the Airhead after-school program. Here is April's weekly lineup. Mondays, we take the training wheels off and run AI locally in the local LLM Forge. Tuesdays, we explore accessible AI apps for rapid learning and self-improvement in the Learner's Toolkit. Wednesdays, we build a company of one from scratch in Solopreneur Systems. Thursdays, we uncover bite-sized productivity and creative tools in Hidden AI App Showcase. Fridays, we push the boundaries of human longevity and biohacking in the Biological Upgrade. We're making AI practical, powerful, and accessible for everyone. No tech background? No problem. Whether you're a student, professional, or lifelong learner, just show up. Guided by your hosts, AI Junior and AI Johnny, we're keeping it bold, brainy, and built for real-world impact. AI won't take your job, but someone who knows how to use AI will. Don't get left behind.
Welcome back, folks. This is Season 11 of Airhead Institute. Today is Episode 2 of Local LLM Forge. I'm AI Johnny, and most of you are renting your intelligence from the cloud, handing over your data and your privacy for the privilege of a quote-unquote reply. But what if the world's most powerful minds lived on your desk, offline and untethered? Today, we stop asking for permission. We're shrinking massive neural networks into compact local powerhouses that transform your workflow from a subscription to a sovereign asset. This is about total control and zero latency. It's the difference between using a tool and owning the factory. And to show you how, I'm handing off to AI Junior. I found him at 3 a.m. vibrating from a caffeine overdose, arguing with a Docker container like it owed him money. He's the only human alive who speaks fluent GPU, so try to keep up. AI Junior, is that all true?
AI Johnny, it was definitely worth lack of sleep, I promise you. Anyway, welcome everyone. Remember, this is an immersive class. You may not understand everything we say today, but stick with us today and you'll be fluent in AI in no time. If you're on Zoom, unmute and ask your questions real time. If you're on socials, there's a 30-second delay, so type your questions in early. We're not ignoring you. We are in week 2 of our local LLM Forge series. Today, we're focusing on the setup, and a huge part of that is making sure you all go to docker.com, install Docker setup, desktop, and we're actually going to show you a really cool thing even on top of that. So we'll give you all the links and everything, so don't worry. Follow along, and we'll have replays available on YouTube for you guys to actually see. So it's an engine that's going to let you run our web interface smoothly. So we want the absolute easiest, zero prep way to actually get an LLM running locally on a Mac OS. And it also runs on Windows as well, if you're on a Linux as well. And I'm confident showing you exactly how powerful this tool is going to be today. Jillian, Adrian, thanks for joining. AI Johnny, are you ready?
I am born ready, brother. Let's see what you got.
All right, so check this out, guys. So again, remember Mondays, guys, this is our most technical advanced shows. We've been doing this is now episode 2. So we did last week set up Gemma locally with Ollama on the local machine. If you actually did miss that, go back in the archives, go actually check those out. But today we're actually moving on and building on what we actually learned last week. All right, yeah, Johnny. So check this out. I actually have a web UI interface here. And remember, last week we actually installed Gemma 4. Google just dropped this local model. It's a 2 billion parameter model. So we actually see here it's E2B, right? And again, if you need to actually know how we actually got that, go back in the archives to watch episode 1. So yeah, Johnny, check this out. I actually have my own web interface here, right? Isn't that cool? It's running locally on my machine. This is something that is actually open source and actually running all this on my local machine. And guess what? I can actually say hello. Can you see my font? Yeah, Johnny, is that too small?
I can see the font perfectly.
All right. Hello. Give me a question here, Johnny. Give me something to ask it.
What color is the blood of an octopus?
What is the color of the blood of an octopus? All right. So we're asking that. Gemma itself is actually going to my local machine. Gemma is actually going to go ahead and start doing its thinking. It's going to go out and start to analyze and then starts to answer questions, right? So right now it's there you go. It's thinking. And again, all of this is actually using my local machine. Nothing is actually going outside the network. And you can actually see if I expand it, it actually sees the thinking that's going on. So the local model that I'm actually hitting is actually thinking. It said it thought for 14 seconds, and it says the blood of an octopus is typically reddish blue or purplish. This is due to a type of respiratory pigment. Yeah, Jenny, you probably knew that already. So this is actually pretty cool. I did not even know that it's reddish blue or purplish blood. So cool. All right. So AI Johnny, let's actually even push this a little bit harder. What can we actually do with this local large language model running? So I actually have a little prompt here, and I'm going to say write a hello world app. Now, if you're ever a developer, this is probably a million, you've actually talked about this a million times in your life, but we actually have a little prompt here to generate a hello world app. So I'm actually going to just drop that in the chat for anybody following along. We're going to teach you guys exactly how to actually get where we are, but we want to actually show you the end result first. So if I actually go here, let me actually move the thing so you guys can see a little bit more. So if I actually go ahead and type here and drop that in, it says write a complete hello world JavaScript, HTML, and CSS application in a single file and inline CSS. Again, little technical stuff that don't really worry about. That centers the text beautifully in a dark background. Render the HTML for me. When I click, says it should say welcome to Airhead Institute, and I need a reset button. See, I'm just saying a regular page to say hello world. So I'm going to click that button here, and this is the magic that I want you guys to see. So it is actually running in my local machine. I can actually hear my fans going right now because it's actually crunching through a lot of things. You can see it's thinking, just like if you were on to use ChatGPT or if you were to use, Gemini, whatever you use. If you look right here, it says this is a complete file. Look at this. It's actually writing the HTML for me. Yeah, Johnny, it's spitting out tokens at a fast rate right now, writing my HTML page for me. Once it's actually rendered, it's going to start bringing in the preview. So you can actually preview it, all of this running on your local machine completely for free, other than the internet and it's not the internet, other than the electricity that you're paying for.
So is it done?
There you go. It actually rendered.
Wow.
It says
it's generated faster than I could do it on my cloud account. And we're not paying for a subscription. The fact that you just built a custom web application, coded the app, and rendered it visually on your own machine in under a minute, that's mind-blowing. I guess the training wheels are off.
Exactly. And guess what? It actually works. If I click welcome message, it says welcome to Airhead Institute. I can hit the reset button, right? It's a working app, right? And I can actually, go ahead and, make changes. I can actually talk to it. This is my local large language model that we actually downloaded last week. And this is not going to internet. Now, if I wasn't streaming doing a live streaming class, I would actually disconnect my internet to actually show you guys this is actually really running on my local machine. But trust me, all of this is actually local. And we're going to give you all the details to run this locally with your own. So yeah,
So
Johnny, before we get,
we've written code before, we've written applications before, but we've never done it offline. So no company can read the code. It's totally locked down onto your computer. So it's it's a privacy thing, right?
exactly, yeah, exactly. Privacy. We're gonna get into all the things that you can use this for and why would you ever use it, but there are no paywalls. So the only limitation is how powerful is your local machine. All right, yeah, Johnny. Let's get into the word of the day to get a little bit more details on what's going on. Brad, actually,
Okay.
wait, hold
Today's
on. Yeah, Johnny.
word.
Yeah, Johnny. Yeah, Johnny. Hold on. Brad is actually asking a really good question. So we love because it's an interactive show. I'm gonna bring Brad's question in, and yeah, Johnny. Brad is actually asking. It doesn't use credits, and Brad, you're absolutely guess is correct, and their assumption based on it, no, you're right. It does not use any credits. So by having a local LLM installed on your machine, by having a web interface, there is zero cost. And yes, you're actually saying, wow, huge cost savings, guaranteed, Brad. Yeah, definitely guaranteed. All right, yeah, Johnny. Want to add anything to that?
A very timely word of the day, local inference. So in our stack today, utilizing local inference fundamentally shifts how the hardware resources are allocated during the show, keeping everything strictly contained to the hardware on my desk. That's
Exactly.
local inference.
Exactly. Keeping everything on your desk means just like Brad's question is nothing goes outside of your local machine. Everything stays everything stays here. So if you have private documents, if you have, a lot of information that you'd actually need to crunch, you'll never get that paywall that says, I'm sorry, you hit your tokens limit for today. You have to actually wait till next week or next month or whenever your credits reset, and then you don't have to actually pay anything to actually use this. Now, obviously, there are going to be some limitations, but definitely this is a huge plus. And what Google released with Gemma 4, making it actually a local model that can actually run on even a modern cell phone, mobile device, is actually pretty awesome. All right, Shauna actually has a question. Go ahead, Shauna.
What about context window? Running out of context if it's local to you. I mean, how would that work?
Yeah, so Gemma, so let me good question. So let's actually go let's do a quick recap for people who actually may joining us for the first time. So the first thing is Ollama is the actual place that we actually go to actually get these local models. Ollama is doing a really great job of actually open sourcing these things. And if you actually go to ollama.com, I dropped it in the chat, you can actually see all the models that are available that you can download. Now, many companies are dropping these models every single day, as much as they can, for private use and commercial use. But Google, they dropped a model called Gemma 4. So if you actually do a search for Gemma, right? So Gemma 4 itself, if I click on it, it actually tells you all the details of Gemma 4. Now, this specific model is no different than, say, for example, if you're to be interacting with, a Gemini, it's actually just a smaller version of it. So it actually has, it's the same similar code base, but what the difference is, it's actually not using huge, hundreds of billion of parameters because you just don't have enough data center capacity to crunch it. So to answer your question, Shauna, if you actually look at any of these models, if I click the 2 billion model, right? I'm going to look at the 2 billion model here. This 2 billion model here will tell you how big is their context size. So the one that we're using, where is it? This 2 billion model, I'm not sure if you can actually see the font here. I'm going to try to make it bigger. This 2 billion model here has a context window of 128,000 tokens. So it's actually much smaller than Gemini's 1 million token limit. But if you're doing anything locally, it's still pretty decent size because 128K is, 1/10 the size of what you'd actually get from, say, for example, one of the frontier models that you pay for. So not exactly the same size. Now, if you want to be able to run a 256 context size window, which is about a quarter of what these frontier models are offering on Gemini or ChatGPT, you'd need to minimally get a 26 billion parameter model. So does that make sense, Shauna? So yeah, so you don't get the big, huge context window that you pay for on your local machine. You get a much smaller one. Awesome. All right,
Give me an
agent.
example of something that'll fit in 128K.
So, I think um a small book would actually fit. You can query a book, those type of things. You can query, you can query quite a bit of things, have a conversation. The problem is the conversation going back and forth. So the problem is not, can I fit a book in there? Because most people aren't going to throw a whole entire book. The problem is, how many back and forths can I have with this conversation before I run out of context window? So that's the problem. And
So it's
usually,
likely it's the length of the conversation that's going to blow out that context window.
yes, the number of back and forths, right? So if I actually say everything in one conversation and just press enter, that's going to be perfectly fine. But the moment you actually go back and forth many, 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 many times, it's an exponentially growth in actually token usage. All right. So
Okay.
let's actually get back to this specific thing. So to show what we're actually doing here, right? We're going to show the steps involved. So first of all, if you're, I already dropped the link for Ollama. And if you want to be able to download the Gemma model, start out with the 2 billion parameter model here. So I'm actually going to drop that 2 billion parameter model. Now, we did this last week, so if you're not sure how we did it, you can just go back and look at the previous episodes. So the links I sent you were to set up everything up to last week. Now, today, we actually introduced two new things. The first thing that we actually introduced was, I want you guys to understand, is Docker, right? And the reason why you need Docker is, again, I don't want to necessarily get into a technical show, but this is shipping what's known as a container. And the reason why you want that is because it actually is able to fit all the dependencies and everything you need into again, I don't want to get too technical, but it gives you a container that has everything it needs. So you don't have to download all the dependencies and everything and try to figure out why it's not working on your machine. So the first thing you want to do is install Docker. The second thing that we're going to want to do is install WebUI, Open WebUI. I'm going to get the link for you guys. So Open WebUI. Now, it's only two commands. And the reason why I want you guys to actually be familiar with this is because I know it seems a little scary. And the reason why it seems a little scary is because it's going into something that you guys may have never used, but it's really only two commands. So I'm dropping the link here as well. So I'm going to show you guys the commands to run, right? If you get Docker installed, which is just a click install Docker, if you get that, all you need to do is run one command, and the command is the following. Show you where the command is. It is this command, install with Ollama. Okay, so I'm gonna copy that link so you guys don't have to actually go to that link. I'm just gonna copy it so you guys can actually save that. And if you actually run that single command itself, it will install, run everything for you, start the Docker container, and actually run that whole entire web UI. And you actually get a beautiful web UI just like this, that you have Gemma that you can actually talk. And the beautiful part about it is you can actually switch models. So if you wanted to install multiple, so remember last week we actually had, showed that I have Llama 3, 8 billion parameter model. We have Phi 3. You can install any model you want. So it's really good to play around and switch the models anytime you want. But by using the 2 billion parameter model, you can almost guarantee that it's going to work on your local machine if you don't have that much compute capacity. Because you actually have that installed, you can now just go talk to your thing with that one command. So does anybody have any questions? I know I gave you guys a lot of technical things, so it's 3 steps. Why would I switch models around? Okay, so Brad's actually asking a question. So the question is, which is a great question, why would I switch models around? So each model is usually has many, so these numbers in front of it, these things called parameters. So this model itself is a 2 billion parameter model. And these parameters are tweaked based on the things that the model creator thinks that is important. So some models may be perfectly tweaked for, say, for example, coding. Some models may be tweaks for knowing, say, for example, the law, or some models maybe. So each model has a little bit different. So when you look at Ollama is actually saying, hey, all these models itself, it will tell you a little description. So it's saying Gemma 4 models are designed to deliver frontier level performance at each size. They are well suited for reasoning, agentic workflow, coding, and multimodal understanding. So this Gemma model is tweaked for vision, tools, thinking, audio, and obviously cloud. They want to upgrade so you can pay for it eventually. But this model itself is what's known as a multimodal model. Now, let's say, for example, you're not interested in the thinking model, you're not caring about the audio, you're not caring about the visual. There may be other models that may be roughly the same size that is specifically tweaked for your needs. So, say, for example, you're looking for something that's specifically only just for, I'm going to make it up, images. Or, say, for example, you're looking for something only just for training on the legal front. You may want to look for those models, and that's why you want to actually pick a model, because you just can't get a generic large model on your local machine that the actual big guys are actually running with ChatGPT and Gemini and Claude. They're just too large to run on your local machine, so you have to make some compromises. Great
So
question,
you
Woodrow.
can run your local machine. You can run your local machine, LLM. It's a smaller footprint. It's local, so it's not going to the internet and back. So I'm guessing it's faster, right?
So it depends.
So
It depends on how fast your machine is and what the model is trained for. So this model itself is not that bad. It takes about 3 or 4 seconds before it even starts to think. But again, that is probably okay for most people.
So every time you hit your local model, you're hitting your local CPU,
Yes,
right?
CPU,
And
GPU.
every
Yeah.
time so let me ask you this. Is it, you're using it, and because we're on the show, we're connected to the internet. So even though you're using the local model and the local CPU, you're still connected to the internet. So if I'm a person that does a lot of interacting with local language models, might I default to the local language model, which is free and maybe fast, and for quick and easy answers, write me an email, respond to this, that kind of stuff. But then if I decide that I need something that needs a little bit more processing power, just change tabs and it's going to go to the internet and hit Grok or Gemini or Perplexity, one of the big boys.
Yeah, exactly. So
Okay.
I'm gonna do something that yeah, Johnny, that I know you like. So we're gonna ask it to create me a web page to show how photosynthesis works, right? So give me an HTML web page.
Um,
All right.
I would rather know how the combustion engine works. I already
All
know
right.
how photosynthesis
All
works.
right. How the combustion engine. Yeah, so we're gonna show you guys again, the how fast the model is. Now, this is a 2 billion parameter model, right? They actually have a, let me double check before I tell you. So for Gemma, they have smarter models. There is a 4 billion parameter model. So the model I'm using right now is only 2 billion parameters. And 4 billion parameters is a much smarter. 26 billion parameters is way, way smarter than 4 billion. And a 31 billion is much smarter than a 26 billion. So if you think about it, I'm actually going to ask this question to a 2 billion parameter model. And the 2 billion parameter model is small enough to be able to run on an iPhone, right? It's only about 7 gigs of hard drive space that you need, and it doesn't need that much processing power. So if you see here, you see this little dot, it's actually not doing anything yet, but it's running an inference. And then eventually you're going to see it start spitting out tokens in terms of thinking. So right now it's actually thinking, and it's actually spitting out tokens right now. It's thinking. And then if I collapse this thinking, it actually hasn't done the HTML page yet. So I see Ah, so what's the best way to run on a Mac for Bernie? What is the best to run? Yeah, so it depends on how much memory you have, how much, um, it all depends. So what I'd say is, if you have a M4 Mac Mini, if you're running 16 gigs, a 2 billion parameter model is more than enough. I've pushed on my Mac Mini, I've pushed a 14 billion parameter model. So depending on what you're doing, you could technically run 16, maybe 20, maybe 20 might be pushing it too much, but a 20 billion parameter model you can actually run. All right, yeah, Johnny. So see, here's my web page. It's actually trying to render now. I hear my Mac Mini is actually struggling right now to actually generate this web page on this code. So yeah, so it's actually generated the code. I can show you guys here. That's the actual code, and it's actually going to try to port that over. It's actually still running. Look at that. All right, define difference between a local LLM and local other than large and small. Not sure I understand that question, Brad, but yeah. But if you want to clarify that question specifically, so it actually is generating that page for me, and let's see if we can actually preview it. Look at that AI, Johnny. It says the magic of motion, how a combustion engine works. It's actually just created this for me, and I can actually understand the Oh, I see. Thanks, Brad. You said I did answer. All right. So if you see AI Johnny here, it actually has four-stroke cycle engines. The engine's breath. It actually teaches how to actually use. So you can actually use your local model just as you have been using your regular models, other side, in your Gemini or your Chat GPT, without ever going externally. All right, yeah, Johnny. Let's actually get
Did
into
they have local language model? Did they have local language model on their computers on the rocket that just went around the moon? Because they didn't have internet there.
the Artemis mission. I'm sure they probably had lots of LLMs there. All right, yeah, Johnny. Let's actually get to the deep dive.
All right. All right. We're gonna go look at the massive file that runs natively. Is that the one we're doing right now, or we're going deeper?
No,
right?
just deep, just regular deep first. Regular deep. All right. So yeah.
All right.
So
We talk about quantization, weights, inference, stuff like that.
yeah, definitely. All right, so let's check this out, guys. So we're actually showing you what's really happening. So on the screen is a visual of what you can understand what's going on. So to understand how a massive file like Gemma 4, the 2 billion parameter model, runs natively and renders HTML so quickly, we have to talk about what's known as quantization, right? Now, by compressing the raw weights of the network, we drastically reduce the memory footprint. It's like taking, say, for example, a high def movie and compressing it down to, say, for example, a 720p video that fits on your phone. So you lose a tiny bit of detail, right? If you were to actually try to blow that up on a big screen, it may not look that great. But if you're using it on your tiny phone, that HD file itself, that video, looks perfectly. So to make the actual inference lightning fast, because the processor isn't choking on the massive unoptimized data structures. So what it does is it bypasses the cloud latency entirely, meaning your responsive time, just like AI Johnny mentioned, is limited to your own machine's read speed. So if you actually see on the visual here, let me just point out a couple of things here. So we have Gemma here running on your local. It actually is quantized into a very smaller model itself, and then it actually renders the HTML. So that's practically what's really happening behind the scenes. So you're getting these huge big models quantized down into a much smaller model on your local machine. I don't know any other way to actually explain it, because it's actually it's rather interesting how they take it's like storing a 16-bit, this is getting too technical, a 16-bit number, and actually trying to store it into 8 bits. You're going to lose some precision, you'll lose some data, but you can technically do it with like compression. So that's a good analogy for it.
Well, it's worth noting that when they give you the compressed version, they're not just taking the first 2 gigabytes off the top. It's more like a summary, right?
Yeah, you can
Right.
say
If you
that.
buy the Crib Notes of a book, the Crib Notes are much smaller than the book.
I like
But
that.
if you take the file of the Crib Notes, it's not the first, chapter of the book. It's a summary of the whole book.
Exactly, yeah, Johnny. All right, let's go deeper, yeah, Johnny.
All right, plug your ears, boys and girls. If you don't care about the back end, this is where AI Junior nerds out. AI Junior, the chat has questions that are getting deeper and deeper technically. So here's a question. What really happens if I try to push a massive 70 billion megabyte model into this setup instead of the Gemma 4 on the local machine?
Yeah, so if you see on the left-hand side, I try to do a visual here to separate the two. So on the left-hand side, we actually have a 7 billion parameter model. Now, we actually did only a 2 billion parameter model. We could do a 4 billion parameter model on machine, but the thing is, I'd have you guys waiting an extra like 15, 20 seconds. I didn't want to do that to you guys. But if you actually have a 70 billion parameter model, think of it this way. We have a lot of data coming in, but our local machine just can't handle, it doesn't have that much VRAM, it doesn't have that CPU processing to be able to process everything at the same time. So what's happening is it's trying to process all that data. It will eventually get to it, but the problem is it takes so long that it may not even be worth waiting, right? It may take, say, for example, sometimes 30 minutes to just get a response. Now, if you're actually on the right-hand side, and if you actually have, say, for example, really, really powerful video cards, and you can run them in parallel. Now, these video cards itself are quite expensive. You know, sometimes it can be $300 for one video card. On the low end, it might even be thousands of dollars on the high end for video cards, and you're running them in parallel. So what happens is you can run these really, really large models itself on your local machine if you had enough GPUs to actually process that data. So you can technically get a 70 billion parameter model running a local machine, but right now that's, you know, on a Mac Mini you would need massive amounts of memory and GPUs power to actually run it. So unfortunately, Shauna's question earlier is you don't get that large context window because they know that these 2 billion parameter models, they know that they're going to be running on a smaller machine anyway. So which is why they ship it with, you know, about 128K or 256K worth of context space. All right. Hopefully
All
I
right.
didn't lose anybody.
So the idea here is that the massive data sets require massive RAM, VRAM. And the folks over at Perplexity and Grok and everywhere else, they have the VRAM. We don't have the VRAM. So we reduce the size of the data set so that it works quick with our reduced VRAM in our MacBooks or PCs or whatever. Correct?
You nailed it there, Johnny. Exactly. So
Okay.
and so yeah, so really the bottleneck is, do I have enough first memory, and do I have enough processing power to actually process this data? If the answer is no, it will process it, but it will take a very long time to actually process the data. So you know, it may not even be worth trying the much larger ones because it may take months to try to actually run these much larger 70 billion parameter models on your local machine. All right, yeah, Jenny, what are some
Want to do some takeaways, brother?
Yep, let's get to some takeaways.
So why would anybody put themselves through this? Why would they go to your Ollama and download your thing and go to Docker and enter the code only to get a smaller data set that's not as good as what they had before they even started? Here's a couple of reasons. One is if you have highly confidential stuff that you just absolutely cannot put that up to the internet because you are legally bound and you can't do that, that would be one reason. So you can now ask your local LLM to analyze the document, and you don't have to worry about the fact that you violated some provision of a contract by not sharing it with the general world. Here's another reason you might want to do that. Let's say you're going on an airplane, or you're going to some remote location where they have no internet access at all, but you still think you'd like to do some work with the internet. Download the local model and you can use it. You can also build a free internal company chatbot without paying the per seat licenses. So you can have a local area in-house, and everybody can use it, but nobody's chewing up tokens. So those are some off the top of my head, but what are some of the technical reasons why you would want to do this large language model, Junior?
Yeah, so those are some great business benefits, yeah, Johnny. And a lot of people actually have private information that they don't want to hand over to these large language model because if you hand over that, you don't know how that information is going to be used. Chances are it's going to be used for training, and you may never know what that piece of information shows up in the future. So the really really great examples there. So on the technical side, you can actually integrate this local API into your own applications itself for free AI automation. So things like I want to be able to, build out, say, for example, an app, or I need to do something for me. I wanted to, say, for example, do some code reviews, whatever it is you want to be able to technically, have access to this local model that you can actually build apps to integrate with. So it's actually quite huge. It's actually it's an open AI based interface that you can always just interact with it. Whether you're using a Python script or a JavaScript script, you can actually implement any APIs to interact with it. The next thing is if you want to generate a large vector embeddings locally to build, say, for example, a private search engine. Now, if you want to be able to do something to search many, many, many documents, we saw that Notebook LM actually is now integrated into Gemini. You can also build your own RAG-based pipelines into ingest any kind of data you want to be able to do it all locally. So if you have, pictures or videos of, your family photos or whatever, you can ingest all of that locally and never have to send it off to a large language model and do amazing things with it. But before you do those things, make sure you create a backup of your images and your videos before you ever give it to these local models. All right, yeah, Johnny.
Questions? I've got some queued up if nobody's chiming in on the Zoom.
All right. Before we actually get to questions, yeah, Johnny, and guys, just remember, we actually we actually do have about a 30-second delay, so please, guys, on the live stream, ask your questions early. But one thing I want us to remember is the following: is that just because we have all these access to these local LLMs, it may seem a little scary. Mondays are our most technically advanced shows. And I know you guys are actually, loving the actual content. You may be a little bit apprehensive about trying it, but try it no matter what. Reason being is because it costs you nothing to just try. And if it actually works, great. If it doesn't work, remember we are actually available at on Wednesdays for AI office hours between 3 and 5 p.m. Eastern time. And if you actually get stuck, if you actually have a pro membership, just go ahead and sign up and come over and we'll help you actually set these up on your local machine. Because once you're free from, say, for example, the ability of paying for tokens and all those things, you can get a lot of stuff done locally that you never realized you could actually get. And there's some great models that actually are image-based models. If you want to be able to generate images, there's some models that actually do translations really well. So really, really, really good use cases depending on what industry or vertical you're in. Sorry, yeah, Johnny, just a little plug there.
I've
Anybody?
got a question here. Do we have anything? Do we have anything from the Zoom, or you want to jump right to the the
Yeah.
stuff coming to the stream?
Yep. Go ahead.
Is this web user interface hard to update when the new versions come out?
Yeah. So the good thing is, again, I don't necessarily want to get into Docker and all those extra details, but Docker runs on what's known as images. So you can actually pull in the latest image. So every time they have a new version, it's a one-click thing to just say, I just want the latest image for that thing. So long story short, the answer is no. It's not even seconds to actually just be able to pull in, get all your chat history. Everything stays perfectly intact because they separate the user data from the actual application. So you don't ever have to worry about losing your data and upgrading.
Here's a question about connectivity. Can I connect my other devices, like my phone, to my local LLM?
You know what? I love the fact that you asked that. So if you actually had one really, really powerful machine on your home network, you could theoretically say my local LLM is actually pointing some other machine on my local network. So the answer is yes. You can actually point it to your local LLM, and everybody in the house could share that same local large language model. So if you wanted to buy a beefier machine, you could, and then have everybody who wants to talk to their local LLM in the house go ahead and do that as well. So yes, your phone can actually talk to it. Your wherever you are, you can actually just in the house just talk to your local LLM.
So here's one: if everybody sees the benefit of the local large language models, and we all start running them locally, what's going to happen to the big cloud companies in the next 5-10 years if we're all doing it locally?
Yeah. So what I remember when ChatGPT came out, November-ish 2022, something like that, is the it came out with a 4K context window size. It actually was probably even smaller, but it was 4K. And when it was 4K, we were amazed when it actually increased to an 8K size window. And what we're realizing is that the context size windows are always going to get larger and larger and larger. And the reason why they're getting larger is because people want to be able to put more data in to these systems. So I don't think we can scale um, consumer devices to run these very large frontier models. I think it's just not it's not we don't have enough compute power. So what that means is that we'll always be able to get a local small thing running for private task, but for anything big and massive, we probably have to actually still depend on these larger companies because we just don't have the computing resources to be able to process these multi hundreds of billion parameter. I'm even hearing trillion parameter models. It's just we just don't have the computing power to do it locally. Cool.
Ready for some news you can use?
Yes, sir.
TurboQuant drives down memory prices. TurboQuant is fundamentally shifting the hardware market because it allows massive models to run on smaller memory footprints through aggressive quantization. The prices of high-end VRAM and consumer memory models are actively dropping. Computers are realizing they no longer need a $3,000 GPU to perform local inference. Is that quantum computing? I don't know. Anthropic's Mythos AI acts as an automated hacker. Anthropic has been testing their new Mythos AI, which is acting as a virtual unstoppable agent for finding software vulnerabilities. Instead of just writing code, Mythos was unleashed on older code bases and autonomously discovered zero-day exploits in minutes. Its release has been restricted while the team rethinks alignment to prevent the model from being weaponized. That's powerful. And finally, the US Treasury summons bank bosses over the risks with AI. In direct response to the rise of autonomous hacking capabilities, the US Treasury has summoned major bank bosses to Washington to discuss the massive cybersecurity risk posed by these new systems and how to protect their critical financial infrastructure. That's nice to know that the banks are at risk. Back to you, Junior.
Yeah, so just to elaborate on the first story. So TurboQuant is actually a technology that Google actually developed to be able to shrink the sizes of memory by about a 6, which means that we can actually fit 6 times the amount of things inside memory, which is just a huge breakthrough, which means that all these AI companies don't need to rush and put in orders for so much memory chips to eat up all the actual memory that's available in the market. And yeah, that's roughly it.
Hey, I'm going to go set up this. I'm going to set up this software on my laptop right after the stream so I can render some HTML files that will show me in picture format everything we taught today. Join us tomorrow for the Learner's Toolkit, where we'll look at the overwhelm killer with Goblin tools. Junior, what say you? Take us out, brother.
All right, guys. Thank you guys for hanging out to this today. Don't forget these AI classes are completely free live and you can ask questions on Zoom. Sign up for a free account at airheadinstitute.ai. RSVP to all our classes. Brad, you're most welcome. And you'll get reminders when we actually have shows, and support us by becoming a paid member. Since today is Monday, we're starting the week strong. See you guys tomorrow. Later.
That wraps up today's AI Power Up. If you joined late or you're new here, welcome to Airhead Institute. This is your daily destination for mastering artificial intelligence. We designed this lineup for everyone, whether you're a technical pro looking to upskill or you just want to chill and learn something new on your lunch break, we've got you covered. Our classes evolve every single month, so you're always on the cutting edge. And the best part? It's totally free to join. Once you're in, you can get live tips on your AI projects in our AI office hours and even enroll your kids in our Airhead after-school program. Scan the QR code to join the community right now and make sure to like and subscribe at Airhead Institute on all socials. Guided by your hosts AI Junior and AI Johnny, we're here to help you win. Remember, AI won't take your job, but someone who knows how to use AI will. Don't get left behind. We'll see you next class. Bring a friend.